Next, second generation architecture, that is federated architecture. So in the federated architecture, joined together, become partner. Each system acts as independently but united. Simply we can say it will be acting as a loosely coupled system. So each and every system will act independently, but it will be joined together in the design. So unlike the first generation architecture, that is centralized architecture, the federated architecture will have data conversion occurs at the system level itself, and then data will be sent in the digital form, which will be called as a digital avionic information system, that is called as Dyas. Then several standard data processors are often used to perform a variety of low bandwidth functions such as navigation, weapon delivery, store management, and flight control. Systems are connected in a time shared multiplex highway. Resource sharing occurs at the last link in the information chain via control and display. Programmability and versatility of the data processor is possible here. Then advantages of federated architecture are it will be contrast to analog avionics. DDP provide precise solution over long range of flight, weapon and sensor condition. Sharing of resources possible. Use of TDMA saves hundreds of pounds of wiring. Standardization of protocol makes the interchangeability of equipment very easy. And then it allow independent system design and optimization of major system. Then changes in system software and hardware will be very easy for making or designing. The fault containment, which will not be propagated here. Then disadvantages are mean only one, that is it is profligate of resources. This is the block diagram of Dyas hardware architecture. Here you will be using different processor which will be connected together, but each processor will act independently to each other. So under the each processor, you'll be having bus control interface for each processor. Different data bus, A bus, B bus will be available. And then each and every processor will have remote terminal and sensor equipment. The last processor will be having control and display equipment, which will be communicating to each other through the data buses. The next second generation architecture is distributed architecture. It has multiple processors throughout the aircraft that are designed for computing takes on a real-time basis as a function of mission phase and system status. Processing is performed in the sensor and actuator. So advantages of distributed architecture are fewer sorted buses, faster program execution, intrinsic partitioning. So disadvantages are potentially greater diversity in processor type, which aggravates software generation and validation. The another type of second generation architecture is hierarchical architecture. This architecture is derived from the federated architecture. It is based on the tree topology. The advantages of hierarchical architecture are critical functions are placed in a separate bus and non-critical functions are placed in another bus. Failure in non-critical parts of the network do not generate hazard to the critical part of network. The communication between the subsystem of a particular group are confined to the particular group. The overload of data in the main bus is reduced. So the most of the military avionic flying today based on the hierarchical architecture only. This is the block diagram of hierarchical system. So these are the blocks which is used for designing the hierarchical system. Ultra high frequency, radio frequency, common and audio management unit, TACON, inertial navigator, left cockpit FU, WFG, 2 WFG is used here, MFD 3 HUD 1 right cockpit, and then avionic bus, that is MIL STD 1553B is used. Then instrument and warning panel is used here. Then flight control computer. Then air data computers are used with the sensor. Then system management processor, 4 system management processor are used, that is A, B, C, D, with the actuator and driver units. So these are the hierarchical system, that is hierarchical architecture.